Now substituting this value of H positive in this pH expression, what we get, pH is equal to minus log H positive, right? So I'm just substituting this expression for this H positive in this figure. So what do I get? pH is equal to minus log this Kw into Ka upon Kc, right? So I can write this expression in this way also. Right. So this is how we are going to write the equation in this form, and we can just have the equation written in a different manner. So that means I can write in this way also, that pH is equal to minus this thing. pH is equal to minus half log Kw plus log Ka minus log C. So this is how we can write this expression in the form, in this form, right? So this is how you're going to get the pH. Again, I'm repeating for you. pH is minus log hydrogen ion concentration. So what I did, I just want to derive this hydrogen ion concentration, and I've just wrote this expression of ionic product of water. Substituting this hydroxide this thing concentration, I just wrote CH. Then I just put the value of H from here, and because it is in denominator, so I just reciprocate it. So in this manner, so I just go and keep solving and putting in the expression of pH, and we are left with this thing. So that means we are done with the third property as well. So whenever you get the anionic hydrolysis, what you have to do, just consider that it is a strong base and it is a weak acid, right? So you know how to write the equation like this, right? So just write an equation, then you can derive the hydrolysis constant, then look for the degree of hydrolysis, and then derive the pH. The similar thing we do in the cationic hydrolysis. The only difference is that the cationic hydrolysis occur when it is the vice versa. That means it is the strong acid and the weak base. But in a similar manner, we are going to just do this process again. The only difference lies in that here instead of Ka, we'll get the Kb, right? And because that means the ionization constant for a weak base. Right. So the similar, that means this will become the Kb in this case, right? And similarly, when we'll look for the concentration here, so again Ka will become Kb. So this is how you just have to replace Ka with Kb, and you will be left with the same expression. So this indicates actually the you can say the cationic hydrolysis. Just you can say you have to shuffle, you have to just this thing replace the Ka with Kb, because in that case we have a weak base. We are going to have a cation getting hydrolyzed. So this is how you have to show the this thing, the hydrolysis, the cationic and the anionic hydrolysis.